Hi folks, welcome back. In my previous video I showed you how to successfully tab a solar cell, and in that video I included all the steps necessary to be able to successfully tab. And this is it. This is what we tabbed in a previous video. Okay, now today what I'm going to do is I'm going to show you how to encapsulate this and successfully. Alright. Today I'm going to show you how I made this, and I'm going to guide you along so that you can also make this. This is an encapsulation machine. What it's going to do is it's going to vacuum out the air, and then it's going to heat the EVA, and I'll explain that more as we go along, to melt the to hermetically seal the solar cells themselves. Okay, so let's get started. Now, in the previous video I had said that the flux that we use is a no clean solder flux, but as you can see it does leave a residue. Now, and I saved this part for the point right before we're going to encapsulate this cell for a very good reason. If you cleaned it right after you soldered it and you set it aside, there would be dust accumulated. So what we're going to do now is we're going to clean this right before we encapsulate it. Now, the first thing I want you to take note of is a little jig that I constructed, because these cells are very, very brittle. And this is simply a wooden frame, hot glued together. I think they're made out of coffee stirrers, measured and cut. And this is what I'm going to use to help reinforce the cell while I'm washing it. And the solution that I'm going to use is nothing more than 90% isopropyl alcohol. It's going to dry very quickly. Another note that I want to make before we go too far in this is this blue coating. That's all it is. It's just a coating. It's carbon vapor deposited on here, and this is the inside. If you manipulate this coating too much, you will rub it off. So that's why we're going to be very gentle in our cleaning process. Okay, 91% isopropyl alcohol is what we're going to use. Of course, you can get this anywhere. Okay. I would not suggest using a smaller container, because what you'll want to do is you'll want to do a little wave action back and forth. Okay, that's the purpose of this larger container, is to just give it a little wave back and forth. You just want the alcohol to wash over the surface without any manipulation from your fingers. It can be stubborn at times. The solder flux can be a little bit stubborn and coming off, so just be patient, and this is the process. Okay, now all you have to do is take it out, and this is where I use the frame. It will suck to the bottom and create a vacuum underneath and make it nearly impossible to get out without damaging the cell if you don't make a little something to keep it off of the surface. We're going to set this aside, and it's going to air dry in just a few minutes, and we're going to air dry it in a closed cupboard so that there's no more dust on that. And as you can see, there's a couple little bits of dust, so I'm going to just drop it right back in there. Keep in mind, the more particular you are about cleaning your cells, the better your finished product is going to perform and look. Okay, completely clean sheen surface. Now I wanted to show you, alright, you can break the cell simply by trying to lift it up off of the surface of the pan. This is why I came up with the frame to handle the cells. Now this is where we're going right to next, okay? This is also my sample piece. Alright, so before we get started, I want to go over a couple of things as to why it's important to be particular in this process. Okay, now here is the EVA. Now EVA stands for ethylene vinyl acetate. That's what this is. This is a product you can buy online. It's very expensive. It will double the price of your solar panel. And it's translucent to begin with. But once you heat it, it turns virtually optically clear. This sample is from China and is completely useless. It's a very small sample. Keep in mind, the reason it becomes useless is you see these creases? They will probably, I would not risk a solar cell with this product right here, so I will not be using this on any product that I plan to use. However, it's okay for slight demonstration purposes for this. Another thing to be particular about is, as you can see from here, you see these light areas here, but that's actually air that's trapped in the EVA. What I did was I simply cut a strip and I used a hair dryer to melt it. It will melt just fine. The reason to go through the extra time and expense to vacuum encapsulate this is so that you can remove this air. Now it's important because the air trapped in there is a couple of different things. There's a slight bit of moisture, but there's also oxygen in there. Oxygen equals oxidation. Over time it will degrade your cell. That's why we want to go through the extra step to make a vacuum chamber for encapsulating your cells. And we are going to begin that process now. I don't think I need to show you how to melt. A hair dryer will melt it, okay? You'll have to pass it over back and forth on high and you will see it melt. And it does, as you can see, turn optically clear. From this to this. Okay, and now for the next segment. Alrighty folks, here's the vacuum sealing heat table that I have constructed, and I'm going to take this apart for you today. I laid up a couple of things here just to illustrate the importance of cleaning the solar cells. Okay, this is a box of 100. I don't even open them until I am ready to begin tabbing in the process. You will be cleaning a lot, and the more you clean and the cleaner that you stay with your product, the better results you're going to have. To begin with, this right here, this is where I lay out the EVA to cut it, so it has that purpose as well. Don't forget, your EVA is going to come in contact with this surface right here, and after that the EVA is going to come in contact with the solar cell itself. So again, clean the surface, just using regular 91% isopropyl alcohol to clean the surface. Simply a ruler there. What I have back here, and I'll move these things along as I go. This is a cut guide right here. Okay, it's nothing special. It's just two metal strips laid side to side with just enough opening here that a knife blade can get in here, and this is where I'm going to cut, just right along here. Okay, I only tab and encapsulate 4 cells at a time. That is the width that I use, the length of cell that I use, the length of my string, and that's why this is constructed so. Be particular in your cleaning. Alright, there's that. Okay, I'm just getting rid of any particulate, any matters of dust, anything that is accumulated. You'll even want to go so far as to do this in a clean room environment. Don't try to do this in your garage, in an open space, certainly not outside. You probably recognize this. This is simply a section of a countertop. You can buy it at Lowe's. So. This is where you lay out your EVA. Okay. Use your ruler here. I've designed this so that the excess lays back, and then I pull forward to my 6 inches. There. And there. There's a half an inch here between where the ruler starts at my 6 inches and where I'm going to cut. The reason I do that is I make one cut and I don't have to go back and trim. So there it is, like that. Lay it on 6 inches. Okay. Plus the ½ inch, that gives you a cut length of 6½ inches. That gives you a ¼ inch all around to seal the cell in the chamber. Just so. There's the one piece right there. Okay, so I'm going to duplicate this, and then I'm going to open up the table, and we're going to look a little bit closer at what's inside here. And here we have 1 gallon size Shotback from Lowe's or Home Depot. They're about $30, I think. So nothing special there. This is a wet dry. The really cool thing about it is it's not expensive. The motor for these little guys are considerably larger than what you would expect. They give excellent suction power. This is an 8-amp motor. Plenty. Okay, so here we go. Now we're going to open her up, and you're going to start seeing some of the little things that I've done here. Okay. All right. The hose for the Shotback. All right. Here's a little port that I installed here. This is the vacuum port for the device. Along the top edge you see nothing more than weather stripping. Not expensive. I think it's a couple dollars per roll. It's the foam. It is the closed cell foam, or the closed cell foam. I think you'll want to get something like that. An open cell would just leak too much air, so look for the densest foam you can find. It has an adhesive on one side. It sticks straight to the stainless steel here. I've left some silicone trimmings in here. Anywhere that there is a chance for air to get in, what I've done is I've just used clear silicone to seal that up. What you're actually looking at here are 2 warming plates from, I think, Macy's or something like that, that I have taken apart and slid together. They're made of stainless steel. These sides right here are actually part of it. What they are essentially is a warming pan for, you've seen where you put your vegetables or whatever in it that you want to keep warm. It maintains the temperature of food above 140 degrees. That doesn't mean anything for our purposes, but it does for the food service industry. It has to be above 140 to prevent bacterial growth. So there's 2 of them here. Now, it was just an experiment. It was one of these things where I tried it and it worked, so therefore I went ahead and took these things apart and made my sealing oven. What it will do is it will create a temperature at this surface right here between 250 and 300 degrees Fahrenheit. That is plenty for the EVA to melt very nicely. Now, I will include in this, as we go along, this is simply a off switch. It's just a little micro switch, and what that's going to do is it's going to control all the electricity for here. It's going to shut off the heat, and it's going to shut off the vacuum when I lift the lid. It's simply nothing more than that. Just going to simply install it right here, so that when I lift the lid, it's a little safety device. That's all that is right there. I like safety. Now, what I did in the beginning, and it's not exactly necessary, but you may want to consider doing it as well. It certainly is good to know what's going on. So I included in this design a temperature gauge and a vacuum gauge. This helps me to know exactly what the temperatures are, what the vacuum is. Don't really see the need for it if it's not a necessary thing. It wasn't expensive, $5 each on Amazon. Drill a hole, install them. Of course, silicone everything, and you've got a visual indication of what your device is going to be doing. The expensive machines, $12,000 ones, you turn on the vacuum. They recommend a 15-minute time where the vacuum is working before you turn on the heat. Same thing with this little guy right here. I turn on the vacuum, I wait 15 minutes before I turn on the heat, and then I let the heat go for another 15 minutes. And I shut everything off, and when I take the cells out, they're beautiful. Now in the next segment, what we're going to do is I'm going to assemble a cell inside here, and we're going to actually run this device from beginning to end. Alright, so now we're going to start the device. I have the vacuum plugged in, and it's connected here at the inlet port. Don't forget. You're always cleaning. I'm going to assemble the cell inside this chamber, and then I'm going to turn on the vacuum. I'm not going to leave the video running while it is running, but I do want to show you how to assemble it. Okay, now the first thing that you want to put in here is, of course, what's typically referred to as your backer paper. I don't use the backer paper. It's an additional expense. My design allows me to use another material, and I have chosen something as inexpensive as aluminum foil as my backer paper. You want to lay in your first sheet of EVA, ensuring that the EVA is not touching the stainless steel surface. Now, it's no huge problem if it does, but you're going to have to scrape it up, and that just more manipulation. Now, at this point, we want gloves. You don't want to give oxidation a chance to degrade your cells. You want them to last their full life of, 30 years or so. It's rather amazing how that little coating can provide electron flow for so long, but that's the science of it. Alright, here we are. Still in the cradle, okay? Taking it out of the chamber. It has dried. It's ready to go, okay? I'm only going to seal one cell for the purpose of this video. so you have a chance to see things in operation. You don't want to kink your wires, okay? Gentle slopes, always. Then your other EV on top, okay? Now it's important that you have a border here to help, all right? So as you'll see that little wrinkle right there, it will come out, hopefully, during the vacuum process. Now, these are sample rolls of EVA. In my production, I buy it on the roll, so it doesn't have these creases. So it's a little unknown right here as to whether the vacuum is going to work on that. I'm fairly sure it will. This little Shotback will deliver well under a -1 atmosphere, and that it should be plenty. So we're going to put the top on now, and you will hear the vacuum start up, and then I'm going to stop the video. And now the vacuum will run during the heating process. Okay, you want to keep the vacuum on during the entire cycle. Okay, so that's it. We're ready to start. I'll start up the vacuum. Forgive the noise, and then I will stop the video. And when I come back, this process will have been completed. I will have vacuumed it for 15 minutes. I will have applied heat for an additional 15 minutes. So it's a 30-minute window here where this will be in the chamber. And then I'll stop it and we'll lift off the top. And here we are, folks. Vacuum encapsulated with EVA in a homemade vacuum chamber with heat. Now in the next video, we're going to go over some of the math associated with solar energy. I'm also going to introduce this. This is a light box that I use to test each cell after I have tabbed and encapsulated it. And I'll briefly discuss how this was made. It's a very simple build. We're going to cover some of the math involved in this. That is why we're going to test the cells, so that we can have a starting point for making these calculations for your house, how to figure out how much power you're going to need, how many cells, that sort of thing, how many panels. All right. So I hope this has been helpful. And as always, until the next video, same GEO time, same GEO channel.